If you're anything like me, you may well have wondered when you receive a smiley face as part of a text or a WhatsApp or whatever, if that smiley face had ears and a neck and then he stood in front of a square window, how much light would get through into the bedroom? And in actual fact, in this question, that's exactly what we are going to answer, because we have a smiley face with ears and a neck, and we are asked to find the area in orange, which would be the amount of light getting into the bedroom if he was stood in front of a square window. Okay, so we're given a few of these things. The radius of the face is 8 centimetres, that's the blue face. The radius of each of the eyes is 2 centimetres. As we'll see, we don't actually need that, that's a red herring. The ear and mouth segments here and here are identical and hail from a circle radius 6 centimetres. The tip of the equilateral triangle nose is at the centre of the face circle, so that means this is the centre of the blue circle, and it's also the centre of the large square. Now, one of the important things about that is, if this is the centre of the large square, that means that this distance here equals this distance here equals this distance here, because that's the centre of the square, and all of those distances are the radius plus that distance, and we're going to use that later on. The nose, moustache and mouth together form a sector of a circle, and the neck is a square. Okay, now this is great practice for college entrance tests on dealing with area of composite shapes and stuff like that. So let's go. How are we going to do this? Well, let's just draw this square like this, and let's draw the face, and we'll draw the ear here, and we'll draw the ear here, and we'll draw the neck here. The way to find the orange area is the area of the large square. So let's just write this down. Area of the square, large square. Take away the area of the face. Take away 2 times the area of an ear. Take away the area of the neck. This is the neck, these are the ears, and this is the face. Now the problem is that we're not given the dimensions of the square, so we have to work that out. But what we're going to do is we'll be able to see that as this is the centre of the circle and of the square, if we can find this distance here, and this distance here, and this distance here, we can work out that the dimensions of the square are equal to the radius of the face plus this distance, and then we can go from there. Okay, so let's enough talking, let's get on with it. So first of all, let's do the area of the face. That's nice and easy. It's just equal to pi times 8 squared, which is 64 pi. And that's nice and easy. Good start. Now, to move on and advance from there, we're going to need to look at this segment, this sector here. Okay, so let's just redraw that. So here is the segment here. We know that this is 60 degrees because we're told that it's a equilateral triangle. So we know that's 60 and we know that's 60. And we know that this segment here comes from a circle of radius 6 centimetres. So we know this is 6 centimetres. We know that's 6 centimetres. And therefore we know this is 6 centimetres because it's an equilateral triangle. Okay, so let's just draw this triangle here. Now that triangle there, here is 3, because it's obviously half of the radius. And this distance here is going to be, by Pythagoras, the square root of 6 squared minus 3 squared, which equals root 27, which equals 3 root 3. And that's going to be really important. And also, let's just do in another colour just to keep things nice and clear. This bit here in black is going to be the radius, because the whole thing here is the radius. It's going to be 6 minus 3 root 3. So we're beginning to get the dimensions of all of the parts. So as we know, that is 6 minus 3 root 3. i.e. this is 6 minus 3 root 3, this is 6 minus 3 root 3, and this is 6 minus 3 root 3. So we can actually work out now the area of the neck, because it is 6 minus 3 root 3 times 6 minus 3 root 3. We know the neck is a square. So the area of the neck is 6 minus 3 root 3 squared. Now let's have a look at the area of the ear. The area of the ear is this bit. And to do that, we need to find the area of the sector minus the area of the equilateral triangle. So the area of the ear is equal to the area of the sector. Well, an area of a sector is equal to pi times the radius, which is 6 squared, times the angle over 360, which equals 6 pi. That's the area, that's the area of the sector. The area of the triangle, the equilateral triangle, is equal to base times perpendicular height divided by 2. Well, we know that the base is 6. And we know the perpendicular height, we worked that out, is 3 root 3 over 2, which equals 9 root 3. And so therefore, the area of the ear is one take away the other, which equals 6 pi minus 9 root 3. And so therefore, the area of 2 ears, so we can now put this in here, that is 6 pi minus 9 root 3. So we're getting there. Okay, so we got the area of the face, which is 64 pi. We got the area of the ear, which is 6 pi minus 9 root 3. And we have the area of the neck, which is 6 minus 3 root 3 squared. Now, let's just have a look at the large square. We know that this is 8. And we know what this is. We've already worked that out. It's 6 minus 3 root 3. So therefore, half of the distance, half of the width of the square is 8 plus 6 minus 3 root 3. And so therefore, the entire length of the square is 2 times that, which equals 2 times 14 minus 3 root 3, or 28 minus 6 root 3. And so therefore, the area of the square is 28 minus 6 root 3, 28 minus 6 root 3 squared, because we know it's a square. Okay, so now we can put all of this together, remembering, so the area of the orange part is equal to the area of the large square minus the area of the face minus 2 times the area of the ear minus the area of the neck. So let's get a bit of space here. So therefore, the area of the orange bit equals, okay, the area of the square, let's make sure we don't make any mistakes here. The area of the square is 28 minus 6 root 3 squared. 28 minus 6 root 3 squared. And then we've got to take away the area of the face, which is 64 pi. And then we've got to take away 2 times the area of the ear, which is 6 pi minus 9 root 3. But 2 of them, because there's 2 ears, 6 pi minus 9 root 3. And then we've got to take away the area of the neck, which is 6 minus 3 root 3 squared. Okay, so now all we've got to do is expand all of this out, being careful. Now 28 squared is 784 minus 336 root 3. All I'm doing is expanding this. Minus 336 root 3, add 36 times 3, which is 108, minus 64 pi, minus 12 pi, add 18 root 3. Now I'm just expanding that one. And then minus, let's keep the bracket in just to make sure we don't make any mistakes with the signs. 36 minus 36 root 3, add 27. So the area of the orange bit is, let's just collect a few of these terms up. 784 add 108 is 892, minus 36 minus 27 is 829. The pi's is minus 76 pi, and then the root 3's is minus 336, add 18 is minus 318, add 36 is minus 282 root 3. So our answer, the area of the orange bit, or the amount of light that would get through the room if the smiley face with ears and a neck stood in front of a square window, is 829 minus 76 pi minus 282 root 3 centimetres squared. Et voila. I hope you enjoyed this. If you did, please subscribe to the Gresty Academy YouTube channel. Thank you.